Okay, so let's we'll come back and we have maybe 10 more minutes to just finish the last part of the lecture. Okay, so this part is about machine learning based performance models. So why we need the machine learning based performance models, right? The first, let's remember the queuing network models. So what are the drawbacks of queuing network models? We see lots of mathematics, right? And also we need to have deep understanding of the system. It requires extensive knowledge of this software and system. Okay. And another drawback is you cannot handle passive resources. What are passive resources? Is the resources that are required for processing but not work themselves, like memory. Why we cannot handle passive resources? Because we treat each resource as a server, right? Independently, right? CPU, network, disk, we treat them independently, right? But for memory, we cannot isolate it from disk or CPU, right? So we cannot handle passive resources. So for example, we cannot predict memory usage. And also only estimate the average metrics, cannot estimate minimum, maximum variance distributions, peak performances. Another drawback is it is difficult to scale to large scale software systems. It is already difficult to handle a small unit. So it is very hard to scale to large and complex software systems. Okay, all these drawbacks do not mean we don't need queuing networks. Queuing network models still very useful, especially for some mission critical software systems. For example, for the software systems in an airplane, right? Or in a software system that needs a very efficient performance features, like those ones working on mobile devices, right? Or those things are working on in an environment where the power is not efficient, is very costly. Okay, so can we what can we do to address this drawbacks? Can we have a different approach? So the answer is, the question is, can we treat the software and the system as a black box? The Q networks is a white box, right? So we need to go to the internal of the system, right? Can we treat the system as a black box? Yes, the answer is, so we can have a black box performance models or machine learning based performance models. So basically, we treat the whole software system as a black box. And we have a workload input, right? And we measure the corresponding performance metrics. So the workloads, such as how many users insert the card at the same time, or in this time period, that is a workload, right? And the performance metric is CPU usage, response time, those are performance metrics. We treat the workload as a independent variable, right? We treat the performance metrics as a dependent variable. So we build a model, fx, which is the relationship between the workloads and the performance metrics, right? Yeah, this is the overall idea of machine learning based performance models. So given workload and measure performance metrics, we can train a machine learning model. We train this model based on historic data, based on data in the past. Then we use the model to predict the performance of the system under certain workloads in the future, right? That is our machine learning model. Okay. Then how to get the workloads, right? How to get the performance metrics. So what are the workloads? So here, a simple way to get workloads is so one way, JMeter, right? When you're writing JMeter, you specify workloads. You already know the input, for example. That's one way. But in the actual environment, in a product environment, you don't have this information. You have actual user using the system, right? But how many users using the system? You can check the logs, execution logs. Execution logs are generated during the execution of the software system, so which recorded important runtime information, such as like one user do this transaction that is usually recorded in execution logs. Based on these logs, so we can connect information about the workloads. For example, here, this workloads, in this log file, so we have different activities, right? Load data by Alice, read data by Alice, read data by Dan, all those things, right? Then we calculate workloads within the 6 seconds, right? The number of load action is 1, a number of read action is 3, number of write action is 1. So these different actions are treated as independent variables, right? Those are workloads information in the 6 seconds. So what are performance metrics? We have utilization, CPU utilization, response time, throughput, power consumption, battery, all these performance metrics. Okay, how we calculate them, right? We do monitoring. We talked about in a previous lecture. We have different tools to monitor the performance of the system, or like you can use JProfiler to monitor the performance as well, right? Or you can use Docker monitoring tool. Okay. Then another step is we need to align the workloads and the performance metrics by fixed time interval. So we want to, for example, in the execution of in this figure, right? So the execution time is divided into small fixed time intervals. For example, every minute or every 30 seconds. So we calculate the workloads and the performance metrics, right? So we have one pair of workloads and performance metrics in each time interval, right? Then we have a data set of the pairs of workloads and performance metrics. Then we can build a machine learning model. How to aggregate the workload variables and the performance metrics into fixed time intervals. For example, we aggregate the data into every minute intervals. So the first one is do the count, right? Like in the example of the workload extract from logs, we do the count. We count how many raise action, how many write, how many other actions, right? It's usually for a workload we do the count. Or we do like other aggregation, like a min, max, mean, median, sum, right? For example, for CPU, we can calculate the average CPU in this 1 minute. This aggregation is usually for performance metrics. Okay, so here I introduce a general idea of machine learning based performance models. And I want you to do one exercise. So this exercise, I already provided with you the code and the data. So you can just run the code, just want you to understand how it works, okay? So what are data given to you, right? You have this workload counts for, so first of all, this data set is for OpenMRS, right? It's actually is running, using JMeter to run OpenMRS to get this performance metrics, and also to get the workload information for every 30 seconds. And the performance metrics also aggregated to every 30 seconds, right? So you have a CSV file. The CSV files contains the information of workload and performance metrics. If a two CSV files, so these two CSV files are basically two data sets. We can use either of them, right? And based on the data, I want to build a machine learning based performance model for OpenMRS, right? I give you a Python code in Jupyter Notebook. It's also shared with you. And in this code, so a linear regression model is used, and another one is a random forest model is also used. You can use either model, right? Or you can use a different model, like deep neural networks. You can use convolutional networks or LSTM. Okay. can choose any model you want to use. But in this example, there are linear regression models and random forest models. Okay, you can download the data and code from this link. Okay, and if you have any questions, you can ask me. Okay, anytime. I will say that this exercise is not mandatory. Okay, if you are interested in machine learning based performance models, I think it's a good opportunity for you to understand the concept. Okay. All right, and that's it for today. Do we have any questions here?